Next, we'll work a problem using parts by mass in calculations. We learned last semester to use density as a conversion factor, but the point of this exercise is to use the parts by mass information as a conversion factor also. What volume in milliliters of a soft drink that is 10.5% sucrose by mass contains 78.5 grams of sucrose? The density of the solution is 1.04 grams per milliliter. Again, you should know how to use density as a conversion factor here, but there's another conversion factor hidden in this problem that might not be so obvious, the 10.5% by mass. That means that if I have 100 grams of solution, 10.5 grams of that would be sucrose. So we can use the 10.5 grams of sucrose per 100 grams of solution as a conversion factor. So let's consider what we're given in order to work this problem. We're told that we have 78.5 grams of sucrose in our solution. We know that our solution is 10.5% sucrose by mass. That means that for every 100 grams of solution, we have 10.5 grams of sucrose. The density of this solution is 1.04 grams per milliliter, so we can convert mass to volume in that way, and we're asked to find the volume in milliliters of the solution. So the conceptual plan here is to convert grams of sucrose to grams of solution through the percent by mass conversion factor. And then, just like we did last semester, we can convert grams of solution to milliliters of solution through the density. So let's go ahead and work this problem. Again, I'm going to just demonstrate with this one, and I'll work the for practice problem next. 78.5 grams of sucrose, we know that's the amount in our solution. We know that we have a 10.5% by mass solution, so 10.5 grams of sucrose is in every 100 grams of solution. So we're using that as a conversion factor, and we need to put the 10.5 grams of sucrose on the bottom. Now we have 100 grams of solution on the top, and we can use the density 1.04 grams per milliliter to convert mass to volume. So now grams of solution cancels and we're left with milliliters. That gives us 719 milliliters of solution. Now we'll work for practice 14.3. What mass of sucrose in grams is contained in 355 milliliters of a soft drink that is 11.5% sucrose by mass? Assume a density of 1.04 grams per milliliter. So this is basically the previous problem in reverse. We're starting with volume. We're going to use the density to convert to grams. Then we'll use the percent by mass conversion factor to convert from grams of solution to grams of sucrose. So with the density, we'll go from volume of solution to grams of solution. Alright, and from the percent by mass, we'll go from grams of solution to grams of sucrose. So let's go ahead and get started. We're told that this solution is 355 milliliters. We know that the density of the solution is 1.04 grams per 1 milliliter. Next, we're told that the solution is 11.5% sucrose by mass. That means we have 11.5 grams of sucrose for every 100 grams of solution. So we can use that for the conversion factor. we put the 100 grams of solution on the bottom because the density is for the solution. And we'll put the 11.5 grams of sucrose, C12H22O11, on the top. Alright, so now we just multiply top times top times top and divide by the bottom, and we get 42.5 grams of sucrose. Next we'll work 4 more practice 14.3. A water sample is found to contain the pollutant chlorobenzene with a concentration of 15 parts per billion by mass. What volume of this water contains 5 times 10 to the second milligrams of chlorobenzene, assuming a density of 1 gram per milliliter? Well, we know that a billion is 10 to the 9th, so 1 parts per billion means 1, let's write this down, 1 gram of solute per 10 to the 9th grams of solution. Now that's if you had 1 part per billion, but we have 15 parts per billion, so we're going to say 15 grams of solute for every 10 to the 9th grams of solution. We also know the density is 1 gram per milliliter. So the way we'll work this problem is we'll convert milligrams of chlorobenzene, which is what we're starting with, we have milligrams, to grams of chlorobenzene through 1,000 milligrams is 1 gram. Then we'll convert that to grams of solution, because we know 15 grams of chlorobenzene is in 10 to the 9th grams of solution. And then we'll convert that to milliliters of solution using the density, and then we'll convert that to liters of solution just to make it look a little bit cleaner because it's such a large volume. So we're starting with 5 times 10 to the second milligrams of chlorobenzene. Alright, now we know that 1 gram of chlorobenzene is 1,000 milligrams because there's 1,000 milligrams per gram of anything, and 15 grams of chlorobenzene is in 10 to the 9th grams of solution. Alright, next we know 1 gram of solution is 1 milliliter of solution. Alright, so let's just take stock in what we've done so far. Milligrams cancels, grams cancels. This is grams of chlorobenzene. Grams of solution cancels, and now we have milliliters of solution, which I guess we could technically stop here, but I'm going to go ahead and convert this to liters, and we know that 1,000 milliliters of solution is 1 liter of solution. Alright, and that gives us 3.3 times 10 to the 4th liters of solution.